Okay, this first question is, well, actually, the whole question, to be honest, is to do with completing the square. We're trying to turn a quadratic expression into a squared expression plus some sort of constant. Now, it's called completing the square because what we sort of have is a little setup. Now, we need an x here and an x here. That's going to give us the x squared that we need. Okay, so this bit's sorted. And then we want the minus 6x. So how are we going to get that? Well, we can put a number here and here, the same number to give me the minus 6x. We can divide the minus 6 by 2 to give us minus 3 and minus 3. And therefore, we've got our square. We've got x minus 3 squared. And that's going to be what this bit here is. However, there's this extra bit that we've encountered, minus 3 times minus 3, which is 9. And therefore, what I'm sort of saying is that x minus, actually, let me restart that. X squared minus 6x is equal to x minus 3 all squared. That's me completing the square, but then I've got an extra 9 coming on, so I need to minus 9 from it. And that's how it works, basically. You always divide, well, when we don't have a number in front of the x squared, you divide this number by 2. And this is why, because you get part of it from here and part of it from here. But then you need to minus the thing that you've halved squared. So it's going to be minus 9. We still, however, got this plus 20. So don't forget about that. That is there. We just dealt with the x squared minus 6x to start with. So the final answer is actually x minus 3 squared plus 11. If you were to expand that back out, you would indeed get back to here. It's the only possible A and B that would work here. Okay, I've taken a bit of time going through that. I've tried to explain diagrammatically what's going on. I think that can really help, actually. If you're somebody who you can't quite remember, what do I do with that number? I know I do something with it. Get this little square out there, and then it'll help you hopefully remember, right, there's got to be an x here. Okay, I'm going to need to halve it. I get this extra bit. I need to minus it. And through practice, you might jump straight into kind of writing this straight down, to be honest. That's the ultimate aim, especially if you're going to go on and do A-level maths, for example, because completing the square comes up there as well. Why on earth do we want to complete the square? Well, this is where part B comes in. This is a quadratic expression, as I said, and it's an x squared one, so it's actually a happy quadratic, I call it. Okay, it's like a smiley quadratic. Now the turning point is this bit down here, where it turns. How can we use completing the square to work out where that is? Well, it's great. We can look at it and we can think, right, this expression here is a square number, so it's always greater or equal to 0. And the larger it is, the higher your function will go. It'll just keep on going. So what's the smallest it can be? It's when this thing here is 0. So the smallest value that this can take is 11. This point here will be something 11. It can't go any less than that. We can't get 10. I can't get a negative answer overall. And what do I need to make this thing 11? Well, it's when this thing is 0. And what do I need for that is when x is 3. So again, enough practice and you sort of just look at the number here and you know that's your y value and you know to make this the negative of this and that's your x value. But I'm trying to explain why it works because that's equally as important, even though it's not being tested in this particular question. So we can complete the square, we can use completing the square to work out the turning point. Good.